Hello, everybody. Today we are looking at a Network Plus study guide. Cert guide, learn, prepare, and practice for exam success. CompTIA Network Plus N10007. So today, we'll be going over Chapter 1, Network Fundamentals. Nothing too complicated in today's episode, yeah. Let's go ahead and get into it. I'll provide a link to this document in the description, but I do plan on making a video for every chapter. So 15 videos. And yeah, I think this textbook is really good if you're looking to pass this exam. So let's go ahead and get into Chapter 1, Computer Network Fundamentals. Chapter 1, Page 1. What comes to your mind when you think of a computer network? Is it the internet? Is it email? Is it the wireless connection that lets you print to your printer from your laptop? Is it the smart thermostat and lights of your home? Yeah, these would be connected to the internet. Whatever your current perception of a computer network, this book helps you gain a deep appreciation and understanding of networked computing. Be aware that although you think of computer networks as interconnecting computers, today's computer networks interconnect a variety of devices in addition to just computers. It's very true. IoT, Internet of Things. I've seen toasters connected to the internet. We're heading towards a world where, I think pretty much everything will be connected to the internet. I even saw the other day, there's this device, it was a startup company. Pretty much, you insert it into your vagina, and it tests for fertility, just like something you would go to for the doctor. Yeah, you can pretty much do that at your home now, and there's even an app for it. Pretty interesting. Examples include game consoles, video surveillance devices, IP-based telephones, tablets, and smartphones. Therefore, throughout this book, think of the term computer network as being synonymous with the more generic term network, because these terms are used interchangeably. Very true. In this chapter, the goal is to acquaint you with the purpose of a network and help you categorize a given network based on criteria such as geography. Geography is very important in networking. Topology. Topology is pretty much the physical and logical configuration of a network. We'll definitely get into that. And the location of the network's resources. An implied goal of this and all other chapters in this book is to prepare you to successfully pass the CompTIA Network Plus exam, which is a cornerstone exam in information IT industry, information technology. Yep, it's all very true. I'm currently studying for the Network Plus exam, but I've spent a few months looking into networking, and I'll say once you get familiar with the basic concepts, it doesn't get into anything too crazy. Page 2, Defining a Network. In the movie Field of Dreams, you heard, "If you build it, they will come." That statement most certainly applies to the evolution of network-based services seen in modern-day networks. Computer networks are no longer relegated to allowing a group of computers to access a common set of files stored on a computer chosen as a file server. True. Instead, with the building of high-speed, highly redundant networks, Network architects are seeing the wisdom of placing a variety of traffic types on a single network. Examples include voice and video, in addition to data. As you will learn in this chapter, the Internet of Things, this is what I was talking about earlier, IoT, means that just about everything wants to join your network, from the lights in your home to many of your household appliances. My opinion on these household appliances, I personally don't want my fridge connected to the internet. It sounds more expensive if something breaks. Yeah, I just don't think it's for me, but it's definitely cool to have in your house, I suppose, if you're into that. One could argue that a network is a sum of its parts. So, as you begin your study of networking, you should start to grasp a basic understanding of fundamental networking components. These components, such as entities as the client, server, hub, switch, and router, as well as the media used to interconnect these devices. The terms client, server, hub, switch, and router. These are pretty basic terms. A client is pretty much software that you're using, server. Like Windows 2016 server. You can do a whole lot of things on that, like create users, group policy, a lot of system administration stuff on servers. Hub, switch, and router all have to do with connecting you to the internet. And media is packets, things that you're sending through the internet. The purpose of networks. At its essence, a network's purpose is to make connections. These connections might be between a PC and a printer, or between a laptop and the internet. That's just a couple of examples. However, the true value of a network comes from the traffic flowing over those connections. Consider sampling of applications that can travel over a network's connections. File sharing between two computers. Video chatting between computers located in different parts of the world. It's pretty incredible how, I can talk to someone from, pretty much anywhere in the world, and with a pretty high quality too. Surfing the web, for example, to use social media sites, watch streaming video, listen to an internet radio station, or do research for a school term paper. Surfing the web, I want to make a video on a Debian Linux distribution called Unix. I'll go ahead and look this up for you guys. Unix, definitely very cool for surfing the web. It pretty much allows you to surf the web without having cookies collected. I want to make a video looking more into this. Yep. It's very cool. We'll definitely look into that sometime. Instant messaging between computers with IM software installed, email, voice over IP to replace traditional telephone systems. Yeah. I'm sure many of you know Discord, Skype. That has to do with networking. A term given to a network's transporting multiple types of traffic, for example, voice, video, and data, a converged network. A converged network might offer significant cost savings to organizations that previously supported separate network infrastructures for voice, data, and video traffic. This convergence also potentially reduces staffing cost, because only a single network needs to be supported rather than separate networks for separate traffic types. So yeah, this is good for a company's budget, less human capital. Overview of network components. So this is where we're starting to get into stuff. Designing, installing, Administering and troubleshooting a network uses your ability to recognize various network components and their functions. Although this is a focus of Chapter 3, Network Components. Sorry guys, I'm a little bit sick. Before you continue much further, you need a basic working knowledge of how individual components come together to form a functioning network. The components to consider for now are client, server, hub, switch, router, media, and wide area network, WAN link to be specific, as a reference for this discussion. Consider 1-1. Alright, so in this figure, we're starting with the client, which in this is your computer. Going to the switch. The switch can transport data between these two clients. The file server is part of the switch. And the switch talks to your router, which your router is connected to the WAN link. And your router can also connect you to the hub with two other clients. I'm pretty sure these are supposed to be two different networks, and your router is supposed to be connecting you between this network with a switch and this network with a hub. It's kind of like two different internal structures for a network. Over here they're using the switch, over here they're using the hub. File server being a part of the switch. So yeah, nothing too complicated going on so far. The following list describes the network components depicted in figure 1-1 and the functions they serve. So now we're getting into these important terms that you're going to be seeing for a while. Client. The term client defines the device an end user uses to access a network. This device might be a workstation, laptop, smartphone with wireless capabilities, or a variety of other end-use terminal devices. So, yeah, pretty much anything you're using on your network is a client, according to this. A server, as the name suggests, serves up resources to a network. These resources might include email, as given by an email server, web pages, as they're offered by a web server, or files available on a file server. And if these definitions confuse you or don't satisfy you, I would recommend going to Google and looking up computer server definition. And yeah, you can read more about it because these are very baseline definitions. A server is a computer that provides data to other computers. It may serve data to systems on local area networks or wide area networks. I mean, yeah, we're still pretty basic, but tech terms, pretty good website. I would recommend you look more into these. Alright, so next we have a hub. A hub is an older technology that interconnects network components, such as clients and servers. Hubs vary in their number of available ports. Later on in this book, and as well as this exam, ports are very important to passing the exam. You're going to have to know all the different types of ports. But continuing, however, for scalability, you can interconnect hubs up to a point. If you chain too many hubs together, network errors can result. And that's a big downfall of using hubs. Too many hubs connected, errors can result. It's very important. As discussed further in Chapter 3, a hub is a Layer 1 device. And when they're talking about Layer 1, they're talking about the OSI model, which I believe we'll be going over next chapter. There's 7 layers to the OSI model. The first 3 layers are probably the most important, but we'll get more into that later. And does not perform any inspection of the traffic it passes. Rather, A hub simply receives traffic in a port, that is, a receptacle to which a network cable connects, and repeats that traffic out all of the other ports. So it receives traffic in a port and repeats that traffic throughout all other ports. Remember, for local area network, also known as LAN, the hub is considered obsolete. This chapter covers it for academic purposes. So yeah, hub. And next we have a switch, which is a little bit similar to a hub. Just a little bit more complicated. Switch. Like a hub, a switch interconnects network components, and switches are available with a variety of port densities. However, unlike a hub, a switch does not simply take in traffic on one port and blast all that traffic out the other ports, just like we mentioned previously. Rather, a switch learns which devices live off which ports, and this is why it's very important to know your ports. It does this by inspecting traffic that comes into the port, inbound traffic, and recording the source addresses. It then looks at the destination address, and if the switch knows the destination address, it forwards the traffic out of the appropriate port, not out of all the other ports. So basically this is saving resources, making it more efficient. It's less likely to have failure. And once again, very important to know all of your ports, as we will learn later. This dramatically cuts down on the volume of traffic coursing through your network. Consider switch a layer 2 device, which means that it will make its forwarding decisions based on that address that are physically burned into the network interface card, NIC, NIC. NIC, network interface card. Let's go ahead and take a look at this. Network interface card. A network interface card. A network interface controller, controller, also known as network interface card, network adapter, LAN adapter, or physical network device is computer hardware component that connects a computer to a computer network. So not too complicated. So continuing, your NIC is installed in a host. That is, any device that transmits or receives traffic on a network. This burned-in address is a media access control address, MAC. Every device has a MAC address, pretty much. The purpose of your MAC address is so that your network knows which device is talking to the network. Like your Xbox has a MAC address, your PS4 has a MAC address, your phone, your PC, everything has a unique MAC address. Your MAC address does not change. It always stays the same. It's really helpful for administrative purposes. Note that today's switches are capable of functioning at higher layers of the network model, but are still mostly considered a layer 2 device. The main network model in use today is the OSI model. That's what I was talking about earlier. This is covered in Chapter 2, the Osi Reference Model. We can go ahead and take a quick look at this. Just go ahead and look up Osi model. I believe there's 10 layers, but the most used are these 7. Layer 1 physical, layer 2 data link, layer 3 network, layer 4 transport. These first 3 or 4 are the most important. Definitely. It's really important to know your OSI model. Alright, so now we're going on to router. As discussed in Chapter 3, consider a router to be a Layer 3 device, which means that it makes its forwarding decisions based on logical network addresses. The most modern networks use Internet Protocol, IP, addressing. Therefore, most routers know what logical IP networks live off which router interfaces. Then, when traffic comes into a router, the router examines the destination IP address of the traffic and, based on the router's database of the networks, that is, the routing table, it intelligently forwards the traffic out of the appropriate interface. So yeah, when you're on your devices, your clients, and you are connected to the internet, your device is using a physical IP address, and your router basically does the job of forwarding your packets or the packets that you're requesting, sending them to the destination, and your router sends it back. If I have Paint, I can go ahead and give you guys a little example here. So say this is your computer. This is your router. And then this is google.com or whatever website you're trying to reach. Your computer talks to your router. Say you're requesting information from IP address 8.8.8.8, which is very common for testing if your network is working. Your router will pretty much allow you to access the internet. There's a whole lot of terms to use here. A popular one is NAT. And what NAT does is it transforms your physical IP address into a public IP address so that you're able to talk to this domain or whatever you're trying to reach and then receive the requested information going back to you. Your router does a lot of the work when you're trying to talk to the internet. So yeah, continuing with router. When traffic comes into a router, the router examines the destination IP address of the traffic and, based off of the router's database of networks, that is the routing table, it intelligently forwards the traffic out of the appropriate interface. And we'll go ahead and take a quick look at a routing table. It's kind of the process that I was just talking about. I mean, a routing table is pretty much what I was talking about, but they're talking about terms that we haven't really went to yet, so we'll go ahead and talk about that in a later chapter. So next, media. The previously mentioned devices need to be interconnected via some sort of media. This media could be copper cabling, it could be fiber optic cable. Media might not even be a cable, as in the case with the wireless networks, where radio waves travel through the media of air. Chapter 3 expands on this discussion of media. For now, realize that media varies in its cost, bandwidth, capacity, and distance limitation. For example, although fiber optic cabling is more expensive than unshielded twisted pair cabling, it can typically carry traffic over longer distances and with greater bandwidth capacity. That is, the capacity to carry a higher data rate. So yeah, just to summarize, media, your different types of cable, pretty much layer 1, physical layer components. You got your hardware. Yeah. Okay, so next we have WAN link. Today, most networks connect to one or more other networks. For example, If your company has 2 locations, and those 2 locations are interconnected via multi-protocol label switching, MPLS network. The link that interconnects those networks is typically referred to as a wide area network link, or a WAN link. WANs and technology supporting WANs are covered in Chapter 7, Wide Area Networks. Wide area networks, you can get pretty complicated pretty quickly. We have a whole chapter devoted to that. And now we are basically done with these terms, and we are heading over to networks defined by geography. Getting exciting. As you might be sensing at this point, not all networks look the same. I would say that no 2 networks look the same. They vary in many ways. One criterion by which networks are classified is how geographically dispersed the network's components are. For example, a network might interconnect devices within an office, or a network might interconnect a database at a corporate headquarters located with a remote sales office found on the opposite side of the globe. Based on the geographic dispersion of network components, you can classify networks into various categories, including the following. This is probably the most common one. Local area network. This is like your house. Wide area network. The internet. Wireless local area network. A WAN. Or no, a LAN, I meant. But wireless. Storage area network, SAN. Campus area network, like a university. Universities are pretty big, so they're not quite a LAN, but they're not quite a WAN. It's kind of in between. Metropolitan area network. I'm pretty sure this is like if you have 5 of the same company in, say, Philadelphia, and you have different ways of connecting your 5 different companies within a city. Personal area network. I believe this is something like Bluetooth. I'm sure many of you guys have AirPods. Your AirPods connecting to your phone is kind of like a personal area network. The following sections describes these different classifications of networks in more detail. Alright, so starting with LAN. A LAN interconnects network components within a local area, for example, within a building. Examples of common LAN technologies you are likely to meet include Ethernet, that is IEEE 802.3, and wireless networks, that is IEEE 802.11. Figure 1-2 illustrates an example of a LAN. Alright, so, pretty basic. You have, one switch, which is connecting to your router, connecting to another switch. It's pretty much just internally talking to each other. You're not connected to the internet. You're in a close geographical distance where wireless or wired connection is enough for you to talk to your other computers in your area. IEE stands for Institute of Electrical and Electronics Engineers, and it is internationally recognized standards body. I guess they're the ones who come up with these numbers. 802.3. I'm not sure how important that is to know. Alright, so next we have a WAN. A WAN interconnects network components that are geographically separated. For example, a corporate headquarters might have multiple WAN connections to remote office sites. A multi-protocol label switching, MPLS, which we saw earlier, and asynchronous transfer mode, ATM, like getting some money, are examples of WAN technologies. Figure 1-3 depicts a simple WAN topology, which interconnects two geographically dispersed locations. So, you have one building using an IP WAN to talk to another building. Pretty self-explanatory. WLAN, a local area network made up of wireless networking devices, is a wireless local area network. WLAN, Chapter 8, Wireless Technologies, deals with this topic in detail. Alright, so next we have SAN. You can construct a high-speed, highly reliable network for the express purpose of transmitting stored data. This network is called a storage area network. High speed, highly reliable. I would assume this is a costly network to construct and maintain. Other categories of networks. Although LANs and WANs are the most common terms used to categorize computer networks based on geography, other categories include Campus Area Network, CAN, Metropolitan Area Network, MIN, and Personal Area Network, PAN. So we are now about to briefly go over these. CAN, personal story from the author. Years ago, I was a network manager for university. The university covered several square miles and had several dozen buildings. Within many of these buildings was a LAN. However, those buildings, centric LANs, were interconnected. By these LANs being interconnected, another network type was created, a CAN, C-A-N. Besides an actual university campus, you might find a CAN in an industrial park or business park. So yeah, like I was saying earlier, university. That's kind of in the name, campus. Okay, so MAN, more widespread than a CAN, and less widespread than a WAN. A MAN, M-A-N, interconnects locations scattered through a metropolitan area. Imagine, for example, that a business in Chicago has a location near O'Hare Airport, and another location near the Navy Pier, and another location in the Willis Tower, previously known as the Sears Tower, for if you live in Chicago, I guess. If a service provider could interconnect those locations using a high-speed network such as 10 gigabits per second, that is 10 billion bits per second network, the interconnection of those locations would form a MAN. One example of a MAN technology is Metro Ethernet, which features much higher speeds than traditional WAN technologies that might have been used in the past to connect such locations. So now we're going to PAN. A PAN is a network whose scale is even smaller than a LAN. For example, a connection between a PC and a digital camera via a universal serial bus, a USB, the thing you plug into your computer and download whatever, your homework, could be considered a PAN. Another example is a PC connected to an external hard drive via a FireWire connection. A PAN, however, is not necessarily a wired connection. A Bluetooth, that's what I was talking about earlier, connection between your cell phone and your car's audio system is considered a wireless PAN. WPAN, wireless PAN. The main distinction of PAN, however, is that its range is typically limited to just a few meters. Yep, and if you use AirPods, if you go too far away from your AirPods, they no longer work. And there's actually some other cool stuff about the Bluetooth between your AirPods and your phone, but we can say that for another video. And networks defined by topology. This is what we will be going over next. However, I feel like this video is getting a little bit long, so I'll go ahead and cut it here and continue with topology, which is important to passing your exam. If you like networking or IT in general, I plan on uploading 1 or 2 videos a day, Monday through Friday. Some of the other things I have in mind, I want to go through some CTF courses, capture the flag, starting with beginner and heading towards expert, and maybe going through some other textbooks. I mean, anything you guys want me to go over. My main purpose is to be someone you listen to while you're at work and you can't look at your phone, or you're playing a game and I'm on your second monitor. I just want to talk about different various IT subjects, help you pass some exams, talk about some interesting stuff. I also plan on, doing some projects, talking about some bigger cyber attacks where I have to do a little bit more studying, a little bit more research. And yeah, I will see you guys in the second part of Chapter 1. See ya.